Hi, I'm Chris Group and I am with Aesthetic Advisor. And for those of you who don't know me, a little bit about my background. I am an esthetician and a laser tech and an instructor here in Arizona. I also have my Master Aesthetics license and educator's license up in the state of Washington. I have a med spa here in Arizona and also a laser school, and I've been training in this space for probably about a decade or so. I am joined today with Dr. Larry Group, and we are going to be putting out a series of videos called Skinteresting Conversations. Why? Because in aesthetic school, I didn't have the opportunity to learn a lot more about the skin than what was being offered, which is basically the layers of the epidermis, the dermis, and then sometimes the subcu. So what we're going to talk about today is some of the other things that are going on in the epidermis and how the skin cells are connected to each other. So, Dr. Group.
You know, what separates the practitioners that are getting the most money, have the best results, and have the happiest clients with the best referrals are the people that have really mastered every bit of how these procedures work. And in order to be able to do that, you really have to have a real intimate knowledge of the skin. Things we're going to talk about just a little bits at a time really help as a theoretical background, and then later on we're going to put it all together and it'll sort of make sense why something happens, and then you can kind of adjust what you're doing. Let's say like in a chem peel, the timing of that, or microneedling, what depth we're going to, things like that all have to do with the structure and function of the skin. Unfortunately, a lot of times in aesthetic school and even in medical school, dental school, nursing school, we spend a little bit of time on that, but either we forget it or we don't spend enough time reinforcing what that has to do with what we're doing. As skincare professionals, we kind of pretty much should review this stuff all the time. So by having these skin-interesting conversations, we take 10 minutes or so and kind of just go into a topic and sort of see what's going on. Today, we're going to talk about epidermal junctions. What keeps these skin cells together? What keeps the skin, the epidermis, from just falling off from the dermis? How do messages and how does nutrients flow between the skin cells? How does the skin keep water out and keep our blood and bodily fluids and vessels and everything else in? Right. So we're going to talk about today 4 types of junctions. So they're going to be adherent junctions, tight junctions, desmosomes, and hemidesmosomes. We're also going to talk about gap junctions, which theoretically are junctions, but are a little bit different than the other 4. So let's get into this. I know you were dying to do a conjunction junction once you're functioning, because Schoolhouse Rocks rocks. So
it does.
Yeah, I'm
it
with
used to. When we look at the epidermis, and if you've gone to aesthetic school, you learn about the different layers of the skin, starting at the top of the stratum corneum and working your way down to the basal layer, which is the living layer. Obviously, the stratum corneum is the layer that's no longer living. But we never really talk about how are those skin cells attached to each other, and how are the layers attached to each other. So we want to talk about what's going on within the epidermis and how are these skin cells attached. They're not just floating around in space.
Yeah, so we have things like tape and stick and wire and duct tape and glue and Velcro to pull things together. So we'll kind of use those as some analogies. So we have tight junctions, adherent junctions, desmosomes and hemidesmosomes, and gap junctions. So let's take it from the top. Tight junctions. So what keeps, if we have water on one side and bodily fluid on another, or air on one side and our bodily fluids on the other, what keeps the skin cells together so that things don't just flow right through between the cells? Why doesn't the cells just have leaky pores like a strainer, like you have spaghetti? Well, you have sort of this tape, if you will. They're called tight junctions. The top of the keratinocytes, or the skin cells, bind together and form a real tight press against each other so that water can't flow through the top and your own bodily fluids can't flow out. So skin cells sometimes, or epithelial cells, sometimes surround a lumen. So like think about your esophagus, okay? There's that lumen is the hole in the middle, and then those cells are built around that. How are those cells connected, keeping the things you're swallowing inside the esophagus and keeping your bodily fluids from rushing past your esophagus and get to where the food goes? Those are all done with tight junctions. So think of that sort of like as tape. You got Scotch tape pushed together and holding those together with some special proteins. Next kind of thing holding the cells together are adherent junctions. And these are cells, these are junctions that actually are fibers that hold two cells together. So in this case, let's talk about skin cells. We have actin filaments and cadherins and catenin. Basically what we have is, imagine if you had the tight junction with the tape over the top holding those two cells together, but now you want something stronger. So you poke some holes and you put some string through that, and you tie it together. That's sort of a adherence junction. So imagine like the laces of your shoes, all those put together, then you tighten that and tie it. Those filaments hold the shoe tight to your foot. They also hold these cells together. So that's the adherent junctions. There's something called contact inhibition we're going to talk about later, which basically says that in a wound, as these cells are moving towards each other, when they touch, something tells them to stop moving, and it happens to be these adherent junctions. Let's get into gap junctions. Now, these aren't holding anything together. These are sort of the tunnels between the two cells or multiple cells. Gap junctions are important because how do these cells communicate with each other? How do they transmit things like oxygen, or how about melanin in the case of pigmentation? Someone has a really smooth, even complexion probably has really a lot of gap junctions that are functioning very well. We also have little gates on the end of this, so we can kind of control what happens to the cells. These proteins at these gates and these junctions together give the cells the ability to have all kinds of functions by what particles are through. And the size of the particle has a lot to do with what makes it through. Later on, we're going to talk about the 500 Dalton rule, which is the size of something. A Dalton is a unit of mass. So think about, you have a pound is a unit of mass. That's sort of like you measure lots of things in pounds. A ton is a really big unit of mass, right? An ounce is a pretty small unit of mass. Well, the Dalton's just a really, really small unit of mass. So we're basically saying that if it's above 1,000 of these really small units of mass, it's too big to fit through the tunnel. Desmosomes are basically, think of those as Velcro holding a cell together. So two cells are wanting to stick together. They need some special fibers. The desmosomes use keratin, the protein that's in cells, that's in keratinocytes. And these are called intermediate filaments. And think about it as you got Velcro fibers sticking together. So we have the tight junctions, sort of like a Scotch tape. And then we have those adherence junctions, with sort of like string between the two. We have the gap junctions, which are the little tunnels. And now we have desmosomes, which are sort of the Velcro holding cells together. Interesting factoid, carcinoma, which is a skin cancer or any type of cancer, basically the cells lose their desmosomes, and this gives them the ability what's called metastasize, or move around. They break off from each other and can move throughout the body and start cancer somewhere else. And then we have hemidesmosomes. And hemidesmosomes are basically very similar to desmosomes, but instead of attaching the skin cells together, they're attaching the basal skin cell to the basement membrane, or the dermis. So if we didn't have that, the epidermis would just peel away from the dermis. There's something called pemphigus and pemphigoid that affect desmosomes and has hemidesmosomes. And what we're saying is that those anchoring fibrils aren't there, so that the basal keratinocyte just pulls away from the dermis. Together, these anchoring fibrils, the desmosomes, that's the Velcro, the gap junctions, which are the tunnels between the cells, the adherence junctions, which is sort of like the string on a shoelace tied together, and the tight junction, which is sort of like tape. All of these junctions and structures and proteins form this junctional complex that sort of allows our skin to move, allows nutrients to pass through them, but also form a barrier structure that has integrity. You can push on it, it'll bounce back. So all of these things work together, and these particular proteins, the absence of them, too much of them, or problems with them are the source of many of our diseases that we talk about. And a lot of how we do our procedures, if we have a really good working knowledge of what structure, like say a chem peel is trying to target, we're better at it. We understand the nuances of when to stop. We become a little bit more focused practitioners with better results, and better results makes more money. So that wraps up our interesting conversation on junctional complex of the epidermis, and hopefully you had some fun with some terms. Do you want to finish off with conjunction junction? What's your function? You've been dying to do it for 10 minutes.
I know. Okay, so how many of you done Schoolhouse Rock? Conjunction junction, what's your function? hooking up things like freezes and closes.
So good thing you're good. Good thing you're great at aesthetics.
Yeah, thank
right?
God I have a different job because that one would really.
That's pretty bad. All right,
yeah.
thanks. Take care.
Bye bye.